Welcome to General Structures 2 and Lateral Forces, Lesson 4, Example number 3. And it gives us an 8-story shear wall building is 100 feet high and 120 foot long. What is its C value? So first we're going to go ahead and draw the supposed building. So it's 100 foot high, 120 foot long. So this is going to be just a general sketch. So there's your ground line, and it was what, 120 foot, so 100 foot high, 120 foot long, and you don't have to sketch this out, there's no reason to really. And what, 8 floors, so let's cut that in half, cut this in half, cut this in half, and then cut everything in half. Alright, so there's your building. Now it's 8-story. I'll just go ahead and write that down. And it also says, what is C value? And if you look on page, what is it, A2, you'll see that C is your C coefficient, in other words, and it says it's equal to 1.25 S. I slowly drew that S so it doesn't look like a 5. And then T over, not over, T to the 2/3 power. So now you have two unknowns as opposed to having your one unknown, which you have to figure out those two unknowns, S and T, to figure out what your C value is. The S value is seemingly simple. You go to the table, which is reproduced from the UBC. And on page 83, you can see it's table 16-J, site coefficients, and I do not have UBC, so I cannot verify that. But there it is, and it is asking us to pick out a value. So it looks like you have type 1, S1, S2, S3, and S4. And it looks like these are based on soil profiles. It says soil profile, soil profile, soil profile. And we do not know anything about the soil. So you can say, well, how do we guess that? And if you look on page 83, you can see that it says, if the soil properties are not known, soil type S3 is usually assumed, which has an S value of 1.5. So 1.5, and you can say it's assumed. ED. Well, that was ugly handwriting. And then we also need to find T. And you can go ahead and see that the equation for T equals, and you won't have to memorize all this stuff. This stuff will be in the UBC or the IBC, these different equations. And I'm not saying that they're exactly the same equations, but you can do CT, so you're introducing another HN and another unknown, and that they may be coefficients. 2 to 3/4. Alright, so now we have to figure out what T is, and you need to figure out what TC and HN is to obtain that. And the good thing is, we can figure that out. HN is, let's change colors here. HN equals the height of the building, which equals 100 foot. Which we have it right over here, as you can see. And then you can see that CT is based on it says for steel moment, the type of moment resisting. You can have your steel moment, you can have your reinforced concrete moment resisting brace frames, and then that's eccentric brace frames, remember. And this is what it says there. Or it says 0.02 for all other buildings. And in this case, I believe we had a 8-story shear wall. So shear wall is not one of the top two, so we're going to say that CT equals 0.02. And I'll say for shear wall other, since it's not named above. Alright, so this is how I would go about writing on my calc paper. I would say how I came about that. Don't just write CT equals 0.02, but most people, that's probably what they will do. They will just put it directly into their equation, or they might not show it at all. Who knows? They might just go ahead and skip over the whole thing and just assume something for a C value. It kind of depends on who you're dealing with and whatnot. Anyways, moving right along. Now we can go ahead and solve for t. So let's do that. We have what? T equals ct, which is 0.02, hn, which was 100 foot, and then we have a 2 to 3/4 power. So I'll get my calculator out and do 0.02 times 100 to the parentheses 3 divided by 4, and we get 0.63, I'll go to 3 sig figs, 632, let's say. And one thing I would want to make sure on is units. You need to figure out what your units are. And you need to make sure that this HN, what unit, and is actually in feet. And that will give you T of seconds, which it doesn't really match up to say, oh, well, that makes a lot of sense. And I don't have the UBC to see if it says, hey, you know, this H is in feet, or CT is in, what would it be? CT would be, I'm guessing here, seconds divided by foot, 2 to 3/4 or something like that. I don't know what units it would be, and I'm not really gonna, or it wouldn't be 2 to 3/4. It would just be seconds over foot. So you multiply it out, and you end up getting seconds. Just memorize as for right now. Hopefully it says in the UBC, but T is period, and therefore it's seconds. And once again, I cannot explain why that is at this point, because just assume that it would not be in inches. If you have to guess and it doesn't go out there and 100% say, hey. So right now, as assumption, that's supposed to be in foot. It really doesn't say in the study guide, but hopefully it does in the UBC when it explains what it says. It'll say T is in seconds, CT is a variable with unitless, and then HN is in foot. Hopefully it says that. Anyways, I've gone on for a few minutes about that ridiculousness, and I will go ahead and move on, because we weren't asked to find T, we were asked to find C, which now we have T, we also have S, and we can go ahead and solve. So let's put C equals 1.25. Let's input S, 1.5. I'm assuming it's unitless. And then T is 0.632 seconds. So this would give you 1 over seconds. But once again, this is not given any. Let me see where I'm assuming C is also unitless. Let me go ahead and calculate it and see what it is, and then see if our 1.5 divided by 0.632. Our answer is 2.85. It's at 4.8, but with sig figs 2.85, and that is our answer for C. What is C? There it is. And I never like how these units really don't work out, but you'll get used to it. And this 2.85, with my understanding, and please go ahead and throw some questions up if my understanding you think is incorrect. But this C, and remember it's not CT, it's C, it's kind of what I would call a Mach number. And I know I use that loosely, so please don't say it's not a Mach number. But 2.85, I would say that is, this building is seeing 2.85 the force of gravity. So if you got a C of 1.00, it would say, oh, that's exactly kind of like the force of gravity. Instead, you're seeing a 2.85, and it's 2.85 times the force of gravity. And that's generally how I like to think about it. If you think about it a different way, please tell me, and maybe you have a better way. All right. Thanks, and I will see you on example number 4.